This is Jezero crater. Today, it is a hostile landscape too bitterly cold and dry for any living thing to survive. A few billion years ago, however, Jezero might have looked similar to Earth's own Lake Salda in Turkey. Back then, Mars owned a thicker atmosphere. It warmed the planet enough for water to flow and lakes to form in craters like Jezero. Such conditions could have supported the beginnings of life. But did this warm environment last long enough to foster microbes? And why did Mars change so drastically? NASA's latest Mars rover, Perseverance, will investigate these questions by collecting Martian rock and soil samples that may one day return to Earth. On the outside, Perseverance might look familiar. The rover's design borrows much from its older sibling, Curiosity. But on the inside, Perseverance holds something new: the sample caching system. This sophisticated machine will drill into the Martian surface and remove, image, and store chalk-sized cores of rock and soil. Eventually, the rover will cache more than 30 cores for a future mission to pick up and send to Earth for intensive study. We can't learn much from these cores until they make their journey home, but Perseverance has more than one trick up its sleeve. The rover is outfitted with tools to discern the chemical makeup of rocks and soil. By mapping the distribution of organic molecules in a rock, these tools could help scientists differentiate between organic debris from meteorite impacts and the remains of microbial life. Perseverance will spend its first 2 years exploring Jezero and collecting samples on a meandering path from lakebed to shore. The rover's primary mission is to seek signs of past life, but researchers will also use the data to investigate the geologic and climatic history of Mars. Beginning its journey on the dark crater floor, Perseverance will likely find a volcanic landscape frozen in time. If this surface is in fact fossilized lava flow, researchers may discern the lake's age thanks to radiometric dating. Next, the rover should encounter fine-grained clay at the edge of the delta, which sits at the mouth of an ancient river that fed into the lake. On Earth, these clays often preserve biosignatures, so here Perseverance will look for organic compounds that could betray the existence of past microorganisms. Continuing its quest for ancient life, the rover will traverse rough sandstone. The grains of this sandstone might be billions of years old, having flowed downriver from some of the oldest terrain on Mars. If this is the case, researchers could study the magnetic signatures of these early rocks to unveil the history of the Martian magnetic field. One theory suggests that the field shielded a thick atmospheric blanket that once warmed the red planet, and when the field failed, the atmosphere dissipated and the climate changed. To culminate its mission, the rover will seek the carbonate-rich shores of the ancient lake. These limestone-like carbonates are known on Earth to preserve stromatolites, mounds formed by bacterial growth. Thus, this is an ideal place to look for such geologic time capsules of past life. Scientists are also interested in these minerals because they are scarce on the surface of Mars, despite an atmosphere that today is 95% carbon dioxide. Studying these rocks could reshape our limited understanding of the Martian carbon cycle. Perseverance is the first Mars rover designed to seek signs of ancient life, but that's not the mission's only first. One instrument will record sound on the Martian surface for the very first time. Another, the Ingenuity helicopter, will attempt to demonstrate the first powered flight on another planet. A challenging feat, since the Martian atmosphere is 100 times thinner than Earth's. If successful, Ingenuity could pave the way for future flight-driven exploration on the Red Planet. More than 50 years ago, humans retrieved rocks and soil from the Moon for the very first time. These samples completely reshaped our understanding of the Moon's formation and continue to be studied today. We can only begin to imagine what similar samples from Mars might teach us about the Red Planet, our solar system, and perhaps life itself.